Here's example 2 for compound interest. Okay, so we have our formula A equals P times 1 plus R over N to the NT power. So this time we're going to try and find R. We want to have $15,000. Right now we have $10,000 invested, and we would like to have that in 8 years. We're compounding annually, so that means n equals 1. That makes this problem a little bit easier. So that means we'll have 1 times t. So 1 times 8 is just 8. We'll reflect that later. Okay, so I'm going to go ahead and divide by the 10,000 on both sides. That gives us a ratio of 1.5. So we're trying to get 150% of our money. And then we're going to have 1 plus r. We don't need the over 1. 1 plus r to the 8th power. So to get rid of an 8th power, we don't even need to use a logarithm. All we have to do is do an 8th root. So the 8th root of 1.5 is equal to the 8th root of 1 plus r, which actually cancels out our 8th power. So this goes away, and we end up with r equals the 8th root of 1.5, and then we have 1 plus r, so we're going to subtract the 1 from that answer. So now all we have to do is put that in a calculator. There's a couple of ways to do an 8th root. Usually you can choose a button on your calculator that has like an X there or something. You can type in an 8 to get an 8th root, or we could do 1.5 to the 1/8 power, because an 8th root is the same as a 1/8 power. Then after we calculate that, we'll subtract 1 from it, and that will give us the rate r. So putting that in my calculator, I get 1.5 to the 1 divided by 8 power, and I get 1.05198956. I'm going to subtract 1 from that, so that is 0.05198995. I don't think I need that many decimal places. I didn't tell how many decimal places to do, so let's just round our 1 to a 2, because 98 is pretty close to that rounding up. So then we will have a 5.2% interest rate in order to achieve our goal. All right, the interesting thing is we can actually compound interest continuously if we use the value e. Now, up to this point, we've been using e, but we didn't know exactly what it meant. So we're going to explore e a little bit here, because e is defined as 1 plus 1 over n to the nth power. You might recognize that from the formula we've been using. But e is accurate as n approaches infinity. As n gets bigger and bigger, e gets more and more accurate. We do the same thing with calculating pi with computers. The bigger and bigger radius and diameter that we use to calculate pi gives us a better and better, closer answer. And the idea behind this is n is the number of compounding. So as n gets bigger and bigger, that means we're compounding more and more often, almost to the point of just continuously compounding it, like always earning interest on our interest. That's when we get this number e. So we take the formula we just learned, which was a equals p times 1 plus r to the RT power, and replacing this with e simplifies this to p e to the RT power. So let's go ahead and explore e so we can kind of see what e turns into. If you want to, you can use your calculator to find e. Go ahead and find the e on your calculator, or search it up, Google it, whatever. And if I do that, my calculator tells me that e is 2.718281828. And of course that keeps going. It's a number like pi, a transcendental number that's irrational, never ending, goes forever, and we don't know what the ending of it is because we don't because computers keep getting more and more powerful, we get it more and more accurate, but the assumption is that it never actually ends. Talking infinity here, right? So let's go ahead and plug in some numbers. So that would give us 1 plus, I don't know, should we try what we've been using, like monthly, compounding monthly? Let's go ahead and do monthly and see what value we get for e. So I'm going to put that in my calculator, 1 plus 1 divided by 12 to the 12th power. And that gives me 2.613. So you can see it's a little bit off from this, but the bigger and bigger numbers we use for compounding, like if we wanted to compound daily, that would be 365 approximately, so to the 365 power. So 1 plus 1 divided by 365, and then take that to the 365 power, and I got 2.71456742. You can see that I'm getting closer to what my calculator says E is. Let's not worry about what the time frame is. Let's just choose a really big number to plug in here. Let's maybe do like 10,000. I was going to go ahead and say let's multiply 365 by 24 and do this hourly, but it's okay. Just pick a big number to see that the bigger number we plug in, the closer we get to the value that our calculator tells us is accurate. So 1 plus 1 divided by 10,000, and then take that to the 10,000 power, and we get 2.718145927. So you can see how much closer and closer this is getting to the value of E in our calculator. So that's where this formula comes from, is from replacing this value of E by increasing n infinitely close to compounding continuously.